Okay, so we're back here for part 2, and we're on the back of the first page. So we're going to do an activity here and try to determine if the results that the Mythbusters got were significant or not. So in this activity, your class will investigate whether the results of the experiment are statistically significant or if they could have occurred purely by chance due to random assignment. All right, so that's what we're going to try to do here on the second page. We're going to start with the null hypothesis. And the null hypothesis, that's not the thing that we're trying to show. That's where the null hypothesis is what we start from. And what we're going to say for the null hypothesis is that the difference of the true proportions is 0. All right, now that's another way of just saying that the proportions are actually equal. Whether somebody yawns in front of you or does not, we're saying that that doesn't have any effect on whether you will actually yawn. So if we say the proportions are equal, that's how we're almost always going to start. That's the same thing though. If I move the proportion of the second, if I move P2 over to the other side, I would just subtract. So in other words, their difference is 0. There is no difference. So what this is saying is that the treatment doesn't affect whether or not the person yawns. So when we write the null hypothesis, we start it from the assumption that, look, there's nothing special going on here. Okay, these are really the same thing. It doesn't matter whether the person's yawning or not. The alternative is what we're trying to show. We're trying to show that there's evidence that says that these are actually not going to be the same. Okay, so for now though, we're just going to stick with our null hypothesis, that the difference of the proportions is actually 0. Now the 50 people in the experiment are represented by cards. Now we're not going to use cards. If we were in class, we would have cards with 50 values on the card. And a person will either yawn or they will not yawn. So of the 50 people, the 50 cards, some of them will yawn, some of them will not, no matter which treatment they are randomly assigned. So we're going to shuffle the 50 cards. Okay, and I'll come back to this again because we don't have cards. And we're going to put them into 2 piles. One is the group of 34. Those were the 34 people that received the yawn seed. They get the yawn seed. And then one group of 16 that does not get the yawn seed. So this would be our first sample, N1. And then the 16 would be our second sample, N2. Record the proportion of people who yawned in each group. We're going to do this 3 times. Okay, so the idea is that the Mythbusters used 50 people. Well, we're going to do something 50 times. Now, in this case, I'm going to use my random number generator on my calculator. Okay, so RNG, I'm going to use a random number generator, 1 to 50 with no repetition. Okay, so if I set this up, I can go math, go over to probability, and then I'll go down, to random integer no repeat. And we're going to go from 1 to 50. Now, let's say that the numbers 1 through 14 are the people who actually yawned. In the experiment, 14 people ended up yawning. Okay, if I go back to the front here. So did the subject yawn? 14 of them did, 36 of them did not. So in terms of assigning our values here for the random number generator, let's say that numbers 1 through 14, those are the people that yawned, and then 15 through 50 are the people that did not yawn. Okay, so we'll set that up. Now the other thing is though, that the first sample, the people that received the yawn seed, there were 34 in that group. And then there were 16 people that did not receive the yawn seed. Okay, so it was 34 and it was 16. So if I do this random integer no repeat, enter. Now the way that I did it, and I've actually realized there's a much simpler way to do it, as I look at my values, the calculator is randomly assigning the numbers from 1 to 50. And if you look, my first 5 numbers were 35, 39, 6, 8, and 30. Now out of those first 5, 6 and 8 are part of the yawn group. Okay, so I'm going to keep track of this. I'm going to count here. So it was 2 out of 5. 2 of the first 5 did yawn. Now that sample size was 34 people. So what I'm going to do is take the first 34 of these numbers. Those were the people that received the yawn seed. Okay, so 5 of them, out of 5, 2 of them got it. Now I'm going to go to the right. 30 was my last value there. In the second group of 5, 9 and 3 are part of the yawning group. So again, that was 2 out of 5. All right. So out of the first 10 here, 4 of them are yawners. All right, now in the next 5, the only one that's a yawner that does yawn is 7. So that's 1 out of 5. So we've looked at 15 now. Okay, 1, 2, 3, 4, 5. So go to 32. Now in the next 5, the only one that yawns was 4. So out of 20 people, 6 of them are yawning so far. Now I need to go to 34 to do this experiment. 13 and 12 are part of the yawning group, 1 through 14, so that's 2 out of 5. And that goes up to 26. All right, and then the number 5 is part of the yawning group, so that's 1 out of 5. So 5, 10, 15, 20, 25. So I've done 30 trials, 2, 4, 5, 6, 7, 9. Now I've got to get to 34 people because that's the number of people that received the yawn seed. So I'm going to go to, let me count here. I got to count 4 more people. 24, 38, 31. So no, no, no. 14 is a yawner. So that's 1. Okay. Now that took me a while to go through that. And then the people that are left over are the 16 people that did not receive the yawn seed. So the proportion who yawned in the yawn seed group p hat 1. 2, 4, 5, 6, 8, 9, 10. So it was 10 out of 34, because I counted 34 of the numbers. And so what that means, if these 10 people yawned, remember there were a total of 14 that yawned, so that means there's 4 left over, and we've already counted the 34 that received the yawn seed. That means that 16 did not. So actually, this is what they had when they did the experiment. Those are the same exact numbers. So the difference in proportions, if we subtract these, we end up getting the 0.29 minus the 0.25, which is 0.04. Okay, now that's one sample that we did. We need to do more than one sample. Okay, so I'm going to show you a couple of my results. I've done this 20 times. And to be fair, I really want to do this more than 20 times to come up with, a really good idea of what's happening. But I'll show you that the results that I got, and this took a while because I had to count everything up. I had to keep doing it. So one of the examples I got, I had 9 people in the first group who yawned, which means that 5 of them did not in the second group. And when I subtracted that, I ended up getting a negative decimal value, negative 0.0478, so about negative 0.05. There was actually one group that I did. There was one trial where all 14 yawners were in the first group of 34 that I chose. So these were the people, this is the group that received the yawn seed. 14 of them ended up yawning, which means that none of the other group did. So that was kind of a crazy situation. But when we're dealing with random chance, yeah, that's possible. It's unlikely to happen, but it is possible that it does. The difference in those proportions was 0.4118, so 0.42. Okay, so that's a huge difference right there. Now, in number 6, make a class dot plot of the difference in proportion. So I've already plotted. These are the 20 times that I went through this process. If you wanted to do this yourself and add in more, it would give us a better idea. Now, this is not the sampling distribution. The sampling distribution is where we look at all the possible sample sizes that we could get. This is not all the possible values that we could get. Okay? This is what we call a randomization distribution. And remember that we're doing this where we are assuming that it is equally likely that a person yawns in either group. That having the yawn seed actually has no effect on whether you yawn or not. So when we did this random generator, we're saying, look, it's a random chance that you can yawn. It's purely by chance that this can happen. Here's what the distribution was that I got. Now, the randomization distribution of, we did p hat 1 minus p hat 2. And these were all the differences. So notice that we had differences that were negative. So that means that we had a higher proportion of people that yawned in the second group, okay, like this situation right here. We had values in the positives, and the way that they're distributed almost looks about the same, to be honest. Now, if we want the p-value is the probability that we get some value either equal to or more extreme than whatever that number is. And we want to see what's the probability of that happening. Is it likely? Is it unlikely that if this is occurring by random chance, that this would actually happen? Now, in the experiment, what they got was 0.04. Now, if I look at my dots here, these were all 0.04, and then this is more. So the p-value is going to be these number of dots so the number of circled dots divided by the total number of dots. And so if I count that up, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's actually 10 here. 10 dots were circled. I did this 20 times. So it's 0.5. Assuming that the null hypothesis is true, assuming that there's actually no difference between whether you have a yawn seed or not, the probability that we get a difference of 0.04 or more extreme is actually 50-50. In this case, if you did this again, or if I did more of these, this number might change. It might go down, it might go up for that. So the p-value is 0.5. So in what percent of the class's trials, so in these trials, did the difference in proportions equal or exceed 29% minus 25% equals 4%? Well, in my trials here, it was 50%. It was 0.5, which means that, again, we shuffled this up. We did this randomly, and the values that we got, getting 0.04 in the experiment is actually not that unlikely. It happened a lot. It happened half the time that we got 0.04 or higher. So what conclusion can you draw about whether yawning is contagious? Well, if this were a significance test, we would reject H naught. We would reject that we would fail to reject, excuse me. We would fail to reject the null hypothesis because 0.5 is much higher than a significance level of, say, 0.05 for that. So we would not reject H naught. So we're going to say we don't have convincing evidence that yawning is contagious. Now, we didn't do the actual significance test. To do it, we would have to have more of these because, as you're going to see on the next page, we've got conditions that we have to meet if we're going to do a significance test. So that is the end of part 2.